All right, today we're going to go through the last section of chapter 10, which is talking about circles in the coordinate plane. So basically writing equations of circles and then taking an equation of a circle and graphing it. So the first thing, the circle can be centered at two different locations. So the first place could be at the origin. So what we're looking at here is the center of the circle is right at the center of our XY coordinate plane. And so basically what's happening here is if we want to write the equation of a line or equation of a circle, what we have to remember from earlier in the chapter is that any point on the circle, so if I put a point right here, or a point right here, or a point right here, or the point that we have marked right here. So any of those points that I marked right there are all the same distance away from the center. So if I were to take any radius and draw it out to the edge, all of these radii would be exactly the same. Now, as we're looking at this then, that tells us that we can find the equation of a circle by recognizing the fact that the x and y coordinates can be used to calculate no matter where we're at. So calculate where we would be on the circle no matter where we're at. And so we do that using Pythagorean theorem. And so what you notice here is when I have my radius, which is in red, okay, it goes out to this point xy. And so what we notice is that means we went right x units and up y units, and now we can create this little right triangle here. And from Pythagorean theorem, we know that we can take our a squared plus our b squared and set it equal to our c squared. And so if we replace that with my x, y, and r, we get this equation right here. So if we have a center where of a circle with a center at 0, 0, so a circle at the origin, then we can go ahead and set up Pythagorean theorem. If we know a point, we can do x squared plus y squared equals r squared. And so as long as we know what the radius is, we're able to write the equation of the line. Now, the circle's not always going to be at the origin. So it might be moved to a different location. So if we move the circle to a different spot, so here we're moving it up to where we're calling HK for right now. So we went right H units and up K units to get my circle center, but the rest of it is exactly the same. This radius, highlighted in red there, is the same all the way around the circle. And we're going to use the same Pythagorean theorem idea to solve for my equation. And so in this case, the first thing I need to find, I'm going to highlight this in purple, is my horizontal distance. Well, on a number line, we can calculate distance by subtracting the coordinates. So from h, I went x units to the right, and so that's that x minus h right there. And then in blue here, I'm going to highlight the vertical. And so if I want to know how high up and down we went, from k, we went y units up. And so that's where we take that y minus k from our distance calculation. Well, so if I take that a squared plus my b squared and set it equal to c squared, we end up with this equation right here. So basically all you need to know from here is whatever the center is, we put the h coordinate right there, we put the k coordinate, so x and y, and then we have our radius at the end. And so if we kind of put this into practice so you can see what that looks like, one of the types of equations you're going to be expected to know how to do is working with something like this. Here's the graph of a circle, give the equation. Well, so the first thing we need to do is when we're looking at the circle is identify the center. So here we have a center at the origin. So my center point, which I'm going to put up here, is at 0, 0. So as soon as we're at the origin, I already know that I'm just going to write x squared plus y squared equals, and now I need to find the second part of my equation. And so the second part of my equation is the radius. Well, so on the radius, I could try to find points and use the distance formula around it, but we said that no matter which direction we head, we have to go the same distance no matter what. So the easiest way to do that is just go straight to the right. So if I go straight to the right until I meet my circle, I can go ahead and count how far I traveled. So I went 1, 2, 3 units to the edge, and so my radius would have a length of 3. And so since my equation says take x squared plus y squared equals r squared, 3 squared would be 9, and there's the equation of my circle. Okay, now one thing I will caution you on when you're looking at these types of graphs, be aware that they're not always going to have the coordinates go by ones. Like for this case, they went 1, 2, 3. In some cases, they might actually take it and do something like this. So if I change this with a 4 all the way around, and so now what they're telling you is instead of going 1, 2, they're going 2, 4, 6. So really pay attention to the numbers they give you in the graph, because those are going to tell you exactly what you need to count by to get that radius. But once you have that center point, count straight to the right for your radius and then plug it into your formula accordingly. Same thing on this other example here. So the first thing we do is find the center point, which is at -1, +3. So there's our center right there. Now, as far as using the formula, so as I start to set up my equation, we're going to take x minus -1 squared. So we always do x minus the center, and then y minus the center, 3 squared. And now the only thing we need is the radius. Now they gave us a point here, so I could try to do distance formula from -5, 6 to -1, 3, and that would give me my radius. But we just got done saying the radius is the same no matter which direction I go. So if I instead just head straight to the right, again, I can count how big my radius is. So I can go 1, 2, 3, 4, 5 units, and so my radius would be 5. And so if I take 5 squared, I get 25, and here's the equation of my circle. Now, this x minus -1, I want to talk about that real quick. So if I do x minus -1, minus a negative makes it positive. So a lot of times, and this is what we're going to kind of do as we go through this, if I get a negative center coordinate, I'm going to not write it as minus negative, I'm going to write it as x plus 1. So the equation will always have the opposite sign of its center. So we can look at that right here. So I had -1 for x, but when I plug it in my equation, it's +1. I had +3 for y. When I plug it in my equation, it goes to -3. So you're always changing the sign back and forth from equation to graph or point and back and forth. Okay? Now, the other thing I want to talk about real quick while we have these graphs here is what happens if they ask you to graph a line. So this was finding the equation. What if they say, here's the equation, graph it? So if we start with this left example here, we'll go with an origin problem. So if they say the equation is x squared plus y squared equals 4. So x squared plus y squared equals 4. So now the x squared y squared means the center is at 0, 0. So I plot that point. So I'm right at the origin there. And then the 4 tells me that r is the square root of 4, which is just 2. And so what that means is if I want to draw my circle, I need to go 2 units in each direction. Now the easiest way to do that is go 2 units to the right, go 2 units up, 2 units to the left, and 2 units down. If I get those 4 points, then all I have to do is connect them to make my circle. And we're not judging you by how artistic you can be on this, as long as you have the center marked and you have the 4 points in each direction and then you connect them with a circle. That's all we're looking for. Now if we move the center, so let's say they tell us that our equation is x minus 2 squared plus, actually I'm going to go x plus 2 squared plus y minus 1 squared is equal to 9. So x plus 2 squared plus y minus 2 squared equals 9. So now that I put a shift on my center, remember we always go with the opposite sign of the equation. So plus 2 in the equation means my center's at -2 for x, and then -1 on y means I'm going to go to +1 for y. So my center point is going to be at -2, +1. Now, if I'm going, once I have the center point, then the next thing I need to know is my radius. And so if my equation says 9 there, then that means my radius is the square root of 9, which is 3. And so just like we did on the last example, we're going to go to the right 3 units. We're going to go down 3 units. We're going to go left 3 units, and then up 3 units. And then we just draw our circle through the points. Okay, so as we're graphing, that's all we're going to do. Pull out the center, pull out the radius, and then just plot both, and then just connect the dots as you go. Now, they're not always going to give you pictures or ask for pictures. The other thing they might do is just give you a description. And so if they give you just a description, as long as you have center and radius, you've got everything you need. So for this first example over here, if they tell me the center is -2, +5, in my equation, I go x minus -2, which would be +2, so we change the sign, squared, plus y minus 5 squared is equal to, now my radius is 7, so I square that and I get 49. And then that's my equation, and that's it. I don't have any work to show or anything to do with that. Now, if we look at the second example, this one's just a little bit more involved, because if I notice, they give me the center, which is good, but then they give me the diameter. And I don't want diameter for my equation, I need the radius. So if we remember, the radius is half as big as the diameter, so my radius in this case would just be 5. And so then from there, I can plug everything in. I get my x minus 1 squared plus y minus 4 squared is equal to 25, and there's my equation. So once you have the center and the radius, those are the two key pieces. Whether I'm writing the equation, whether I'm graphing it, or if they give me the graph and they want the center and radius, then that's what I'm looking for. So it's just those two pieces that I need to have going on. So with that, you should be able to work on the worksheet that you got in class or got off of Google Classroom. Make sure to ask questions if you have any, or check the answer keys as it becomes available to you so you're ready for anything on that.